There were several students absent the day that I went over the Unit 7 test outline, so I thought I would make a quick video just to explain what's on this test, how it's going to be formatted, and a little hint on the flashback questions for this test. This is a 2-day test. Day 1 is all the multiple choice questions. These are going to be 3 points each, 13 from this unit, 7 flashback questions. In general, those should be quick. You're going to be able to skip 1 multiple choice question with iHeartCalc. If you get all multiple choice questions correct with no skips, you get a 3-point bonus. I plan to time this at 40 minutes. Okay. Day 2, 40 unit circle trig values and a bonus question. 1 point each. 1 point each. Okay. No credit will be awarded if the sign is wrong. Okay. We're going to time this at 30 minutes. So you need to know these unit circle values really, really well. The bonus question we'll try to make a little bit quick. All right, flashback possibilities. Giving you some flashback possibility hints this time. Average rate of change. How do you find the average rate of change of a function? Find the average rate of change of a function. That is your old Algebra 1 slope. Change in y over change in x. So I'm going to write that as change in f over change in x. Okay. You'll be given 2 x values to find the average rate of change of the function on for all average rate of change problems. Okay, be familiar with the graph of y equals e to the x and y equals ln x. You guys, there is, it's crucial that you know the shape of these 2 graphs. All right? You don't really need to know all of the many, many transformations, but you need to know those 2 graphs. So what do those 2 graphs look like? They are inverses of each other. For the graph of y equals e to the x, y equals e to the x would look like this. It's the exponential growth. Exponential gets larger and larger and larger. That is y is equal to e to the x. For the graph of ln x, it has symmetry with respect to the line y is equal to x. It does this. Okay. That is the graph of y is equal to ln x. So we have symmetry with respect to the line y is equal to x. Okay? Because they are inverses of each other. They undo each other. Inverses. Okay? And then know how to answer questions about these graphs. Okay? Increasing, decreasing, concave up, concave down, relative min, relative max, points on the graph, etc. What is that y value? That y value is 1. What is this x value? That x value is 1. Points, ln of 1 is 0, ln of e is 1. Okay? Because e to the 0 is 1 and e to the 1 is e. Alrighty. Know how to expand logs or compress logs using your log properties. Log properties. Okay, so if you have ln of x plus ln of y minus ln of z, what can you do to combine those into a single log? You can write that as ln of a single log. X is with a positive log, it goes on top. Y is with a positive log, it goes on top and gets multiplied. You multiply those. Z is with a negative log, it goes on the bottom. Okay? What would you do if there was a 2 out in front? What could you do with that 2? You could move it to the power on the x. The power on the x. It's always the power on the argument, not the power on the log. So this would be x squared up there. So know how to combine to a single log and know how to undo that. Know how to go backwards. Break it into its parts. Basic series concepts. Arithmetic, geometric. Know your series concepts. Know what to do to find a term in a series. if it's arithmetic or geometric or otherwise. Okay, know how to write a formula for a series and then use it to find a term. Okay, series, we had a bunch of equations, we had a bunch of formulas. Okay, for this test you don't need to know those formulas. Okay, just know those concepts. Alrighty, but in general, there are several formulas for this. I'll have to talk with Mr. Wolf and Mr. Fisher, and we'll see which formulas you need to know for the exam. Alrighty. Okay, rational functions. These are all really important concepts for us, you guys, and that's why we put them as flashback questions. We wouldn't put flashback questions that are not important. So these are all things that you need to take with you to calculus when you get there. You need to have a really good understanding of rational functions. Okay, and behavior, vertical asymptotes, horizontal asymptotes, silent asymptotes, and holes. Let's do a quick review here. What if I have this function? I'm going to go ahead and factor the top and bottom. Let's say x plus 1, x minus 2, x plus 3, and on the bottom let's do x plus 2, x minus 3, and let's do x plus 1. Okay, where does this rational function have a hole? Well, the hole occurs when x is negative 1. Hole is when x is negative 1. How do you find the y value at that hole? To find the y value at that hole, you get rid of these two and you put negative 1 in for the remaining x's to get your y value. Okay, so in this case, that y value would be negative 1 minus 2 times negative 1 plus 3 divided by negative 1 plus 2 times negative 1 minus 3. So this would be negative 6 over negative 4, which is 3 halves. So the hole would be at the point negative 1, 3 halves. Okay? How do you find the vertical asymptotes? The vertical asymptotes. Well, the vertical asymptotes would be, you look on the bottom of any factor that is not your hole. Once you take care of your hole, it can go away. Once you take care of your hole, once you note where your hole is, what's happening there, you can take it away. The remaining denominator factors determine your vertical asymptotes. There are vertical asymptotes at x is equal to negative 2 and at x is equal to 3. Would look like this. Okay? Vertical asymptotes. Horizontal asymptotes. Well, first of all, before we go to horizontal asymptotes, what is happening when the remaining numerator factors are 0? Well, those are your x-intercepts. X-intercepts are your remaining numerator factors, what makes those 0. So the x-intercepts would be at x is equal to 2 and negative 3. 2 and negative 3. Okay? All right, horizontal asymptotes. Horizontal asymptotes. So for horizontal asymptotes, we use the limit as x is going to infinity or negative infinity of f. Okay? And for this, again, once we got rid of our hole, we really don't need to use it, or we can go back and using the terms that make the hole, that tell us we have a hole. But either way, this would be, up on top we would have an x squared term, true? And I don't care what else is up there. On the bottom, what would be the highest degree? X squared. It doesn't matter what comes next because x is going to infinity. We only care about the highest degree term on top and the highest degree term on the bottom. If they are the same, then this limit would be the coefficient of the top divided by the coefficient of the bottom, if they are the same, because they cancel each other out. So in this case, the horizontal asymptote would be y is equal to 1. Alright, what if we had another term on the bottom? Let's make it x plus 4. What if we had another term on the bottom to where, I shouldn't say limit, that would be the limit as x goes to infinity there. I forgot to carry my limit over. Then we would have, in this case, we would have the x is going to infinity of f, and this would be an x squared plus whatever on top, and it would be an x cubed plus whatever on the bottom. How does that reduce? That reduces to 1 over x. And the bottom is going to infinity, so the whole thing is going to 0. This would give us a horizontal asymptote of y equals 0. Okay, what if our function had a higher degree on top than on the bottom? Let's say that we had x to the 4th plus whatever on top and x cubed plus whatever on the bottom. Then, as x goes to infinity, this thing is going to infinity. That means you have some sort of a slant asymptote. How do you determine the slant asymptote? You divide. You divide. Synthetic if you can for speed, or you can always use long division, but you have to divide. Okay? When you divide, if you get a remainder, it does not affect the equation of the slant asymptote. Okay? No, the remainder does not affect the equation of the slant asymptote. Alright, so that was a little bit of a brief review of a few key important concepts for us. You might see 1 or 2 or 3 of those on your test.